Hi students, today I am going to start the concept derivative of implicit function and derivative of inverse trigonometric function. In that first I am going to discuss derivative of implicit function. So taking out whatever we learned in the previous class was explicit function. So in this class I am going to tell what is the meaning of implicit function and how to find the derivative of implicit function. Okay. So before I do that, first I learn what is explicit function. Explicit function. So here y is expressed directly in terms of x. Okay. So in the explicit function y is directly expressed as x. Directly expressed in terms of x. Okay. So that is here x and y are separated. Here x and y are separated. That means on the left part y will be there and on the right part x will be there. For example, y is equal to sin x plus x square. So observe here, y is on the left part and x is on the right part. Okay, so I have another example. Y is equal to x square. Okay, here also y is on the left part and x is on the right part. Okay, so here y is directly expressed in terms of x. So this is called as explicit function. In this form, y is directly expressed in terms of x. Okay, so now we want to implicit function. Y is indirectly expressed in terms of x. Okay. So here y is indirectly expressed in terms of x. Indirectly expressed in terms of x. That is here x and y are not separated. That means here x and y are not separated. Okay. For example, x5 plus x square is equal to 0. For example, x5 plus x square is equal to 0. And another example, x square divided by a square plus y square divided by b square is equal to 1. So these two are the examples of implicit function. Okay. So in the implicit function, y is indirectly expressed in terms of x. In the explicit function, y is directly expressed in terms of x. Okay. Now we find how to find the derivative of implicit function. For this, I will use some procedure to find the derivative of implicit function. So in the first step, I am going to find the derivative of y with respect to x. So in the first step, we do derivative of y with respect to on one side. On one side, either left hand side or right hand side. Okay. So next, the last step, we solve for dy by dx. Okay, we solve for dy by dx. So in the first step, we are going to find derivative of y with respect to x. So in the next step, we collect all the terms of dy by dx on one side, either right hand side or left hand side, and then solve for dy by dx. Next, for better understand, I am going to solve some problems in the exercise 5.3. So the question is, find the dy by dx in the following. Okay, find dy by dx in the following. In that first one, 2x plus 3y is equal to sin x. 2x plus 3y is equal to sin x. So here, first I will consider the given function, that is 2x plus 3y is equal to sin x. 2x plus 3y is equal to sin x. To find the derivative of implicit function, so we follow this procedure. Okay. In the first step, we find derivative of y with respect to x. Okay. So in the first step, we find derivative of y with respect to x. So differentiate this function with respect to x now. Differentiate this function with respect to x. Okay. So here 2 is a constant, right? So 2 is a constant. So then derivative of x with respect to x is 1. Okay. Derivative of x with respect to x is 1 plus 3 into derivative of y with respect to x is dy by dx. Okay. Derivative of y with respect to x is dy by dx. So this is equal to derivative of sin x is cos x, right? Derivative of sin x with respect to x is cos x. Okay. In the second step, we collect all the terms of dy by dx on one side. Okay. So here is the only one term. Okay. So dy by dx is only one term. So there is no need to collect the terms of dy by dx. Okay. So now I will transfer 2 into 1 in the right hand side. Okay. So 2 into 1 is 2. So then we have 3 into dy by dx, that is equal to cos x minus 2. So this implies dy by dx is equal to cos x minus 2 all divided by 3. Okay. So dy by dx is equal to cos x minus 2 divided by 3x. Okay. So now we got the solution. Okay. So the next problem, 2x plus 3y is equal to sin y. Okay. 2x plus 3y is equal to sin y. So this is the implicit function, right? This is of the form implicit. So to find the solution, first we consider the given function that is 2x plus 3y is equal to sin y. 2x plus 3y is equal to sin y. In the first step, we find the derivative of y with respect to x, right? Differentiate this function with respect to x. So now we have, here is the constant 2. So derivative of x with respect to x is 1 plus 3 into derivative of y with respect to x is dy by dx, that is equal to derivative of sin y with respect to x is cos y into here is a y, right? Here is a y. So then derivative of y with respect to x. So here I am using chain rule. Okay. So derivative of sin y is cos y into derivative of y is dy by dx. Okay. Dy by dx. Okay. So now I am going to second step, that is collect all the terms of dy by is equal to minus 2. Okay. So observe here, in these two terms we have the common factor dy by dx. Okay. In these two terms we have the common factor dy by dx. So I will take common here. So then we have dy by dx is equal to, then we have dy by dx into 3 minus cos phi. 3 minus cos phi. This is equal to minus 2. This is equal to minus 2. So this implies dy by dx is equal to minus 2 divided by 3 minus cos phi. Minus 2 divided by 3 minus cos phi is the derivative of y with respect to x. Okay. So next problem. Third question. Ax plus by square is equal to cos phi. So consider the given function. Ax plus by square is equal to cos phi. So in the first step we do the differentiation of this function with respect to x. Okay. So differentiate with respect to x. So then we have, so here a is a constant. Okay. So then derivative of x with respect to x is 1 plus b is a constant. Okay. So derivative of y square is 2y into dy by dx. Okay. So derivative of y square with respect to x is 2y into dy by dx. This is equal to derivative of cos y is minus sin y into dy by dx. Minus sin y into dy by dx. Okay. So now collect all the terms of dy by dx on one side. Okay. So now I will transfer this term to the LHS and this term to the RHS. Then we have 2by into dy by dx plus sin y into dy by dx is equal to minus a. Is equal to minus a. So next solve for dy by dx. So that I will take the common factor as dy by dx. Okay. So then we have dy by dx into 2by plus sin y is equal to minus a. Is equal to minus a. So this implies dy by dx is equal to, dy by dx is equal to minus a divided by 2by plus sin y. 2by plus sin y is the derivative of y with respect to x. Okay. So the next question. xy plus y square is equal to tan x plus y. So the next question, xy plus y square is equal to tan x plus y. Okay. So the solution. So first consider given function, that is given xy plus y square is equal to tan x plus y. Tan x plus y. Okay. So now we differentiate this with respect to x. Okay. So observe here is the term x into y. X is one function and y is one function. So here we apply the product rule. Okay. Here we apply the product rule. Okay. So here I will keep the first function as x. Okay. So I will keep first function as x and I will find the into dy by dx. Plus. So now I will keep the second function y as it is. Now differentiate x with respect to x. Okay, now differentiate x with respect to x. So what is the value of derivative of x with respect to x? 1, right? 1. Plus. So derivative of y square with respect to x is 2y into dy by dx. 2y into dy by dx. So this is equal to derivative of tan x with respect to x is secant square x. Secant square x. Plus derivative of y with respect to x is dy by dx. Dy by dx. Okay. So now collect all the terms of dy by dx on LHS. Okay. So now we have x into dy by dx. X into dy by dx plus 2y into dy by dx. Dy by dx. So transfer this to the LHS. That is minus dy by dx is equal to secant square x is equal to secant square x. So transfer this term to the RHS. Then we have minus y. So now solve for dy by dx. For this I will take the common factor as dy by dx from all these terms. Okay. So then dy by dx into x plus 2y minus 1. This is equal to secant square x minus 1. Secant square x minus 1. So this implies dy by dx is equal to secant square x minus y divided by x plus 2y minus 1. X plus 2y minus 1 is the derivative of y with respect to x. Clear? So the next question. So fifth one, x square plus xy plus y square is equal to 100. Okay. So consider the given function. X square plus xy plus y square is equal to 100. So now differentiate this with respect to x. So then we have, so observe here derivative of x square is 2x. Derivative of x square with respect to x is 2x plus so xy is there. Okay, so xy is there. So I will apply the product rule here. Okay, so I will apply the product rule here. So then so take this as u and this as v. I mean x as the first function, y as the second function. Okay, so now I will keep the first function as it is. Okay, as it is. So then find the derivative of second function with respect to x. I mean derivative of y with respect to x is dy by dx. Okay, plus by dx. Okay. So then dy by dx into x plus 2y is equal to minus 2x minus y. So therefore dy by dx is equal to minus 2x minus y divided by x plus 2y. X plus 2y. So therefore we got the solution. Okay. So the next question x cube plus x square y plus xy square plus y cube is equal to 81. Is equal to 81. Okay. Solution. Here also first we consider the given function, that is x cube plus x square y plus xy square plus y cube is equal to 81. Is equal to 81. So differentiate this with respect to x. Differentiate this with respect to x. So then the derivative of x cube with respect to x is 3x square. 3x square. Okay. So here is the two functions, that is x square into y. So here we need to apply the product. So take this as the first function u and this as the second function v. Okay. So I will give the first function x square as it is into derivative of the second function y with respect to x is dy by dx plus, so keep the second function y as it is. So now the derivative of the second function x square with respect to x is 2x plus, so here also two functions are there, right? So here also two functions are there. So here x is the first function q and y is the second function v. Y square is the second function v. So here also we apply the product. Okay. So I will keep the first function as x as it is into derivative of y square with respect to x is 2y into dy by dx. 2y into dy by dx plus, now keep the second function y square as it is into derivative of first function x with respect to x is 1 plus derivative of y cube with respect to x is 3y square into dy by dx. That is equal to derivative of the constant 81 is equal to 0, right? Derivative of constant is 0. Okay. So now I will collect all the terms of dy by dx on one side and I will send the remaining terms to the RHS. Okay. So now we have x square into dy by dx, x square into dy by dx plus 2xy into dy by dx plus 3y square into dy by dx is equal to minus 3x square minus 2xy minus y square okay, minus y square. So now I will take the term dy by dx outside. Okay, since it is a common factor to all these terms. Okay, then we have dy by dx into x square plus 2x plus 3y square is equal to minus 3x square minus 2xy minus y square. Okay? So therefore dy by dx is equal to minus 3x square minus 2xy minus y square divided by x square plus 2xy plus 3y square plus 3y square is the derivative of the given function with respect to x. Clear? So the next question please. So next question, sin square y plus cos xy is equal to k. Okay? So first I will consider the given function, that is sin square y plus cos xy is equal to k. Cos xy is equal to k. So now differentiate this with respect to x. Differentiate this with respect to x. Okay? So now differentiation of sin square y with respect to x is 2 sin y. Okay, is of the form composite function. So here in one function another function is there, right? So in one function another function is there. First I will differentiate sin square by respect to x. So what is the differentiation of x square? Sin square y is of the form x square, right? So what is the differentiation of x square here? 2x, right? So the differentiation of sin square y is 2 sin y into derivative of sin y with respect to x. Okay, into derivative of sin y with respect to x plus it is also of the form composite function, right? So it is also of the form composite function. Therefore derivative of cos xy with respect to x is minus sin of xy. And observe here one more function is there, right? So one more function is there, that is xy into d by dx of xy. d by dx of xy. This is equal to derivative of k with respect to x is 0, right? Since derivative of constant is 0. Okay? So now 2 into sin y into derivative of sin y with respect to x is cos y. Derivative of sin y with respect to x is cos y into derivative of y with respect to x is dy by dx. Okay? So minus into plus is minus sin xy into so observe here. So here is a product of two functions, right? Here is a product of two functions. Therefore I will apply the product rule here. Okay? So I will apply the product rule here. So I will take the u as x as u and y as v. Okay? So the first function x into derivative of the second function y with respect to x is dy by dx plus the second function y into derivative of first function x with respect to x is 1 is equal to 0. So this implies 2 sin y into cos y into dy by dx. So make a multiplication here. Sin xy into x into dy by dx is minus x into sin xy into dy by dx. So then minus into plus minus. So again it is down to the have y into sin xy is equal to z. Is equal to z. So now take a common factor here, that is take a common factor outside, that is dy by dx. Okay, dy by dx. So then we have dy by dx into 2 into sin y cos y minus x sin y. So now I have transferred this to the RHS. Then we have y into sin y. Then we have y into sin y. So this implies dy by dx is equal to y into sin y divided by 2 sin y cos y minus x sin xy. This is also equal to y sin y divided by, so 2 sin y cos y is sin 2y. Okay, sin 2y minus x into sin xy. This is the derivative of the given function with respect to x. Okay, so the next problem. Sin square x plus cos square y is equal to 1. Okay, sin square x plus cos square y is equal to 1. So here also first we consider the given function, that is sin square x plus cos square y is equal to 1. So differentiate with respect to x. Then we have derivative of sin square x is 2 sin x. Again the derivative of sin x is cos x. Okay, plus derivative of cos square y is 2 cos y into derivative of cos y is minus sin y into derivative of y with respect to x is dy by dx is equal to derivative of constant is 0. Okay, so derivative of any constant is equal to 0. Okay, so now I will transfer this function to the RHS. Then we have, so minus into plus, minus 2 sin y cos y into dy by dx is equal to minus 2 sin x cos x. So this implies dy by dx is equal to minus 2 sin x cos x divided by minus 2 sin y cos y. Okay, so here minus becomes plus. So then 2 sin x cos x is sin 2x, right? 2 sin x cos x is sin 2x divided by 2 sin y cos y is sin 2. Okay, so this is the derivative of y with respect to x. Okay, so next we move on to the derivative of inverse trigonometric function. Well students, we all know about the inverse trigonometric functions, right? We all know So now we find the derivative of these trigonometric ratios one by one. Okay. So now we consider the first function. First function, that is y is equal to sin inverse x. Y is equal to sin inverse x. So this implies sin y is equal to x, right? This implies sin y is equal to x. Okay? So differentiate this function with respect to x. Okay? So differentiate this function with respect to x. So then derivative of sin y is cos y into derivative of y with respect to x is dy by dx. Dy by dx. So this is equal to derivative of x is 1. Derivative of x is 1. Okay. So this implies dy by dx is equal to 1 divided by cos y. 1 divided by cos y. Okay. So we all know that sin square y plus cos square y is equal to 1, right? Sin square y plus cos square y is equal to 1. So this implies cos y is equal to square root of 1 minus sin square y. Okay? So cos y is equal to square root of 1 minus sin square y. So now I will replace cos y by square root of 1 minus sin square y. Okay? So this is equal to 1 divided by square root of 1 minus sin square y. Okay? So what is sin y here? X. Okay? So sin y is x. Okay? Then I will replace sin y by x. Okay? So this is equal to 1 divided by square root of 1 minus x square. Okay, this is equal to 1 divided by square root of 1 minus x square. Okay? So dy by dx is equal to 1 divided by square root of 1 minus x square. That is derivative of what is y? Sin inverse x, right? So now I will replace y by sin inverse x. Okay? So then derivative of sin inverse x is 1 divided by square root of 1 minus x square. Okay? So derivative of sin inverse x is 1 divided by square root of 1 minus x square. Okay? So the next one, y is equal to cos inverse x. Okay? Y is equal to cos inverse x. This implies cos y is equal to x. Okay? This implies cos y is equal to x. So again, I will differentiate this with respect to x. Okay? So derivative of cos y with respect to x is minus sin y into dy by dx. Okay? Minus sin y into dy by dx. This is equal to derivative of x is 1. Derivative of x with respect to x is 1. This implies dy by dx is equal to minus 1 divided by sin. So then sin y is equal to square root of 1 minus cos square y. Right? So we know that sin y is equal to square root of 1 minus cos square y. So this is equal to minus 1 divided by square root of 1 minus cos square y. Okay, square root of 1 minus cos square y. So what is cos y here? X, right? So cos y is x. So now I will replace cos y by x. Then we have minus 1 divided by square root of 1 minus x So therefore, derivative of cos inverse x with respect to x is minus 1 divided by square root of 1 minus x square. Okay. So the next function y is equal to tan inverse x. Okay. Y is equal to tan inverse x. So I can write this as tan y is equal to x. Okay, tan y is equal to x. So again I will differentiate this with respect to x. With respect to x. Then we have, what is the derivative of tan y with respect to x? Secant square y into dy by dx is equal to derivative of x with respect to x is 1. Okay. So then dy by dx is equal to 1 divided by secant square y. 1 divided by secant square y. So this is equal to 1 divided by what is the secant square y? 1 plus tan square y, right? 1 plus tan square y is equal to secant square y. This is equal to, what is tan y here? X. Okay, so tan y is x. So then we have 1 divided by 1 plus x square. Okay, so dy by dx is equal to 1 divided by 1 plus x square. What is y here? Tan inverse x, right? So therefore derivative of tan inverse x with respect to x is 1 divided by 1 plus x square. Okay, so derivative of tan inverse x is 1 divided by 1 plus x square. Okay, so next one is, so the fourth one, y is equal to cot inverse x. Okay, y is equal to cot inverse x. So we can also write this as cot y is equal to x. Okay, cot y is equal to x. So differentiate this with respect to x. With respect to x. So what is the differentiation of cot y with respect to x? So minus cosecant square y. Minus cosecant square y into derivative of y with respect to x is dy by dx. Dy by dx is equal to derivative of x with respect to x is 1. Okay. So this implies dy by dx is equal to minus 1 divided by cosecant square y. Cosecant square y. So this is equal to minus 1 divided by, so what is cosecant square y? 1 plus cot square y, right? So cosecant square y is equal to 1 plus cot square y. So again, what is cot y here? X, right? So now I will replace cot y by x. Okay? So this is equal to minus 1 divided by 1 plus x square. Minus 1 divided by 1 plus x square. Okay? dy by dx is equal to minus 1 divided by 1 plus x square. That is derivative of cot inverse x with respect to x is equal to minus 1 divided by 1 plus x square. Minus 1 divided by 1 plus x square. Okay. So next function is y is equal to secant inverse x. Y is equal to secant inverse x. Okay. So again this can be written as secant y is equal to x. Secant y is equal to x. So differentiate this with respect to x. With respect to x. Derivative dx is equal to derivative of x with respect to x is 1. Okay, so this implies dy by dx is equal to 1 divided by secant y into tan. Secant y into tan. This is equal to 1 divided by secant y into tan y is square root of 1 minus secant square y. Okay, so tan y is equal to 1 minus secant square y, right? So again, what is secant y here? X, right? So secant y is equal to x. Now I will replace secant y by x. Okay, so then we have 1 divided by x into square root of 1 minus x square. Okay, so dy by dx is equal to 1 divided by x into square root of 1 minus x square. Okay, so therefore derivative of secant inverse x with respect to x is equal to 1 divided by x into square root of 1 minus x square. 1 minus x square. Okay, so the next function is y is equal to cosecant inverse x. Y is equal to cosecant inverse x. Okay, so this implies cosecant x is equal to cosecant y is equal to x. Okay, so this implies cosecant y is equal to x. So now differentiate this function with respect to x. Differentiate this function with respect to x. Now we have, what is the derivative of cosecant y? Minus cosecant y into cot y. So again, derivative of y with respect to x is dy by dx. Dy by dx. So this is equal to derivative of x with respect to x is 1. Okay, so this implies dy by dx is equal to minus 1 divided by cosecant y into cot y. Cosecant y into cot y. So this is equal to minus 1 divided by cosecant y into, what is cot y? So cot y is square root of 1 minus cosecant square y. Okay, cot y is equal to 1 square root of 1 minus cosecant square y. So what is the cosecant y here? X, right? So now I will replace cosecant y by x. Then we have minus 1 divided by x into square root of 1 minus x square. Minus 1 divided by x into square root of 1 minus x square. Okay? So therefore d by dx of cosecant inverse x is equal to minus 1 divided by x into square root of 1 minus x square. Okay, so derivative of cosecant inverse x is equal to minus 1 divided by x into square root of 1 minus x square. Okay, so what is the derivative of sin inverse x? That is 1 divided by square root of 1 minus x square. So the derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. Derivative of tan inverse x is 1 divided by 1 plus x square. So derivative of cot inverse x is minus 1 divided by 1 equation containing 1 plus x square, then we substitute either tan theta or cot theta. Okay? If an equation having 1 plus x square, then we substitute tan theta or cot theta. If an equation containing 1 minus x square, then we substitute either sin theta or cos theta. Okay? Either sin theta or cos theta. If an equation containing x square minus 1, then we substitute either secant theta or cosecant theta. Okay? So observe here, in this equation we have the term 1 plus x square, right? So in this equation we have the term 1 plus x square. So I am going to substitute tan theta here. Okay? So now I am going to substitute tan theta here. So first consider the given equation. Okay? So first consider the given equation, that is y is equal to sin inverse of 2x divided by 1 plus x square. Okay? Substitute x by tan theta. Okay? So here x is equal to tan theta. Then we have y is equal to sin inverse of 2 tan theta divided by 1 plus tan square theta. Okay? 2 tan theta divided by 1 plus tan square theta. So this is equal to sin inverse of what is 2 tan theta divided by 1 plus tan square theta? So this is equal to sin 2 theta, right? So we all know that sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta, right? So then sin inverse of sin of angle is equal to angle, that is 2 theta. Okay? So y is equal to 2 theta. So what is theta here? Observe here, we substitute x is equal to tan theta. This implies theta is equal to tan inverse x. Theta is equal to tan inverse x. Now I will replace theta by tan inverse x. Okay? So this is equal to 2 into tan inverse x. So y is equal to 2 into tan inverse x. So now I will differentiate this with respect to x. Okay? So now I will differentiate this with respect to x. Then we have dy by dx is equal to 2 into what is the derivative of tan inverse x? 1 divided by 1 plus x square, right? So 2 into 1 divided by 1 plus x square. Okay? So that is equal to 2 divided by 1 plus x square. Okay? So we got the solution. Okay? So the next question is y is equal to cos inverse of 1 minus x square divided by 1 plus x square. 1 plus x square. So solution. First we consider the given function, that is y is equal to cos inverse of 1 minus x square divided by 1 plus x square. Okay? So here also this equation has 1 plus x square. So I will substitute x as tan theta. Okay? So here also we put x is equal to tan theta. So now the equation becomes y is equal to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. Okay? So this is equal to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta is equal to cos 2 theta. Okay, theta is equal to tan inverse x. Now I will replace theta by tan inverse x. Okay, so then y is equal to 2 into tan inverse x. Okay, so now I will differentiate this with respect to x. Then we have derivative of y with respect to x is equal to 2 into derivative of tan inverse x is 1 divided by 1 plus x square. Okay, 1 divided by 1 plus x square. This is equal to 2 divided by 1 plus x square. Clear? So the next question is, y is equal to sin inverse of 1 minus x square divided by 1 plus x square, where x lies between 0 and 1. Okay, first let us consider the given function y is equal to sin inverse of 1 minus x square divided by 1 plus x square. Okay, if an equation containing 1 plus x square, then we substitute either tan theta or cot theta, right? So here it has 1 plus x square. So I will substitute x is equal to tan theta. Okay, so now I will substitute x is equal to tan theta. Then we have y is equal to sin inverse of 1 minus tan square theta divided by 1 plus tan square theta. Okay, so this is equal to sin inverse of, what is 1 minus tan square theta divided by 1 plus tan square theta? That is cos 2 theta. That is cos 2 theta. So by using allied angle formula, we write sin inverse of pi by 2 minus 2 theta. Okay, pi by 2 minus 2 theta. Okay, so this is equal to sin inverse of sin of an angle is equal to angle, that is pi by 2 minus 2 theta. Okay, so y is equal to pi by 2 minus 2 theta. So this is equal to pi by 2 minus 2 into, so observe here I will take the substitution as x is equal to tan theta. This implies theta is equal to tan inverse x, right? Theta is equal to tan inverse x. So I will substitute tan inverse x in the place of theta. So then we have pi by 2 minus 2 into tan inverse x. Y is equal to tan inverse x. So now differentiate this with respect to x. Okay, so differentiate this function with respect to x. Then we have dy by dx is equal to derivative of constant pi by 2 is 0, right? Pi by 2 is a constant, so the derivative of constant is 0 minus 2 into derivative of tan inverse x. Derivative of tan inverse x. This is equal to minus 2 into derivative of tan inverse x is 1 divided by 1 plus x square. Therefore, the derivative of the given function is minus 2 divided by 1 plus x square. Okay, so the next question is y is equal to cos inverse of 2x divided by 1 plus x square, where x lies between minus 1 and plus 1. Okay, so the solution is, here also we consider the given function. So given y is equal to cos inverse of 2x divided by 1 plus x square. So here also it has 1 plus x square term. So I will substitute x as either tan theta or cot theta. cos inverse of 2 tan theta divided by 1 plus tan square theta is equal to sin 2 theta, right? Sin 2 theta. This is equal to cos inverse of by using the aligned angle formula we can write sin 2 theta as cos of pi by 2 minus 2 theta. Okay, cos of pi by 2 minus 2 theta. So this is equal. Cos inverse of an angle is an angle, that is pi by 2 minus 2 theta. Okay. So this is equal to pi by 2 minus 2 into. So here I take the substitution as x is equal to tan theta, right? So this implies theta is equal to tan inverse x. So now I will replace theta by tan inverse x. Okay? So 2 into tan inverse x. Okay? So now differentiate this function with respect to x. So differentiate this function with respect to x. Then we have dy by dx is equal to d by dx of pi by 2 minus 2 into d by dx of tan inverse x. This is equal. Pi by 2 is a constant, right? So the derivative of constant pi by 2 is 0 minus 2 into derivative of tan inverse x is 1 divided by 1 plus x square. This is equal to minus 2 divided by 1 plus x square. Therefore, the derivative of the given function with respect to x is minus 2 divided by 1 plus x square. Okay? So the next question is, y is equal to sin inverse of 2x into square root of 1 minus x square, where x lies between minus 1 by root 2 and 1 by root 2. So first consider the given equation, that is y is equal to sin inverse of 2x into square root of 1 minus x square into 1 minus x square. Okay? So if the equation has 1 minus x square, then we take the substitution as sin theta or cos theta. So here also this equation has the term 1 minus x square. So I will substitute x as sin theta. Okay. So the equation becomes y is equal to sin inverse of 2 into sin theta into square root of 1 minus sin square theta. 1 minus sin square theta. This is equal to sin inverse of 2 sin theta into square root of, so 1 minus sin square theta is cos square theta, right? So 1 minus sin square theta is cos square theta. So then we have sin inverse of 2 sin theta. So here square root and square become cancelled. Then we have cos theta. Okay. So this is equal to sin inverse of 2 sin theta cos theta is sin 2 theta, right? So we know that sin 2 theta is equal to 2 sin theta into cos theta. Okay. So then sin inverse of an angle is equal to angle. Okay, that is y is equal to 2 theta. So this implies y is equal to 2 into. So observe here, we take the substitution as x is equal to sin theta. This implies theta is equal to sin inverse x, right? This implies theta is equal to sin inverse x. So I will replace theta by sin inverse x. Okay? So then y is equal to 2 sin inverse inverse x. Okay, so differentiate this function with respect to x. Okay, so then we have dy by dx is equal to 2 into derivative of sin inverse x with respect to x is 1 divided by square root of 1 minus x square. Okay, so this is equal to 2 divided by square root of 1 minus x square. Okay, so the derivative of given function with respect to x is 2 divided by square root of 1 minus x square. Okay, so the next question y is equal to secant inverse of 1 divided by 2x square minus 1, where x lies between 0 and 1 divided by root 2. 0 and 1 divided by root 2. So the solution is, so first we consider the given function that is y is equal to secant inverse of 1 divided by 2x square minus 1. 1 divided by 2x square minus 1. Put x is equal to cos theta. Okay. So then y is equal to secant inverse of 1 divided by 2 cos square theta minus 1. 1 divided by 2 cos square theta minus 1. This is equal to secant inverse of 1 divided by 2 cos square theta minus 1 is cos 2 theta, right? So we know that cos 2 theta is equal to 2 cos square theta minus 1. So this is equal to secant inverse of, what is the reciprocal of cos 2 theta? Secant 2 theta, right? So reciprocal of cos 2 theta is secant 2 theta. So then secant inverse of secant of angle is equal to an angle. Okay, secant inverse of secant of an angle is equal to an angle. Okay, so so here I will take the substitution as x is equal to cos theta. This implies theta is equal to cos inverse x. Theta is equal to cos inverse x. Therefore, I am going to replace theta by cos inverse x. Okay, so then y is equal to 2 into cos inverse x. Okay, so now differentiate this function with respect to x. Okay, so now dy by dx is equal to 2 into d by dx of cos inverse x. Okay, this is equal to 2 into derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. Okay, minus 1 divided by square root of 1 minus x square. Therefore, the derivative of the given function is equal to minus 2 divided by square root of 1 minus x square. Now we got the solution. Okay, so the next problem. So the last question is y is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square, where x lies between minus 1 by root 3 and 1 by root 3. Okay, so first consider the given function as y is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. Okay, so here I am going to substitute x by tan theta. So the equation becomes y is equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan tan square theta. 1 minus 3 tan square theta. Okay. So this is equal to tan inverse of what is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This is tan 3 theta. Okay. So tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay. So then this is equal to tan inverse of tan over angle is an angle, that is 3 theta. Y is equal to 3 theta. So here x is equal to tan theta, right? Here x is equal to tan theta. This implies theta is equal to tan inverse x, right? Theta is equal to tan inverse x. Then I will replace theta by tan inverse x. Okay? So then y is equal to 3 into tan inverse x. Okay? So now differentiate this with respect to x. Differentiate this with respect to x. Then we have dy by dx is equal to 3 into d by dx of tan inverse x. Okay?